Uranus. It's one of the two ice giants in our solar system and the only planet that spins on its side. Despite the name, being an ice giant doesn't mean Uranus is a frozen ball of ice. Instead, it's mostly made of heavier elements like water, methane, and ammonia-like gas giants like Jupiter and Saturn, which are mostly hydrogen and helium. Approaching Uranus, you'd first need to avoid crashing into its rings. Once you make it through, you'd find yourself surrounded by a toxic atmosphere filled with methane gas. Temperatures here drop to a bone-chilling minus 120 degrees Celsius, making Uranus the coldest planet in the solar system. If the freezing cold and poisonous air didn't take you out, descending deeper would seal your fate. The atmosphere thickens and you'd be bombarded by ice pellets as you fall. Then you'd reach one of Uranus' most fascinating features, a rain of diamonds created by the intense pressure crushing carbon atoms together. The winds here reach 900 kilometers per hour, and the pressure quickly rises to 100 times that of Earth's. Your body or even the strongest space suit wouldn't stand a chance. Neptune. Neptune, the second ice giant, is often considered Uranus' twin. With a similar composition, Neptune is a planet of extremes. Being 30 times farther from the Sun than Earth, Neptune is incredibly dark and bitterly cold in its outer layers. However, deep inside, the pressure and heat build up to staggering levels. In fact, Neptune's core burns at around 70 degrees Celsius hotter than the surface of the Sun. Like Uranus, Neptune experiences a spectacular diamond rain, where methane is crushed by intense pressure and transformed into solid diamonds falling like raindrops. Neptune's ferocious winds are the fastest in the solar system. These supersonic storms rage at speeds over 2,000 kilometers per hour, faster than the speed of sound on Earth. In many ways, Neptune is like Uranus but more extreme. If you ever found yourself falling through its atmosphere, you wouldn't last long before freezing, suffocating, and getting torn apart by the monstrous winds. Mercury? Mercury is the closest planet to the Sun, but that doesn't mean it's always scorching hot. While daytime temperatures soar to a blistering 430 degrees Celsius, nights are brutally cold, dropping to minus 180 degrees Celsius. This extreme temperature swing happens because Mercury has almost no atmosphere to trap heat, just a thin exosphere that offers little protection. The real threats are intense solar radiation and the complete lack of breathable air. Being so close to the Sun, Mercury gets nearly 7 times the sunlight Earth does. As the smallest planet in our solar system, Mercury is covered in craters, cliffs, and rough terrain, making landing incredibly difficult. With no thick atmosphere to slow down spacecraft, touching down safely is a major challenge. Landing during the day is impossible. The latest NASA space suits can only withstand up to 121 degrees Celsius, nowhere near Mercury's peak heat. Nighttime isn't much better, as the frigid cold goes beyond the suit's lower limit of minus 157 degrees Celsius. A safer option might be the Terminator Zone, the area between Mercury's day and night sides where temperatures are more balanced. But even there, conditions can shift rapidly, making survival tricky. Venus. Venus is the closest planet to Earth, sitting just 40 million kilometers away. A trip there would take around for months. The first thing you notice on approach is the thick, yellowish clouds covering the planet. They're actually made of highly corrosive sulfuric acid, which would destroy your lungs in seconds if you breathed it in. But let's say you're wearing an advanced space suit that keeps you safe. As you descend, visibility would drop dramatically because Venus' dense atmosphere is mostly carbon dioxide, making the surroundings hazy and difficult to see. Then comes the heat, and unbearable for 150 degrees Celsius. If that wasn't bad enough, only about 10% of sunlight reaches the surface due to the thick cloud cover, meaning it would always look dim and gloomy. Walking on Venus would also feel strange. Although gravity is almost the same as on Earth, the atmosphere is so thick that moving your arms and legs would feel like pushing through water. Even with a high-tech pressurized suit, you wouldn't last long. The atmospheric pressure is about 92 times what we experience on Earth, equivalent to being nearly a kilometer underwater. Your suit would be crushed in moments. Mars. Mars is the second closest planet to Earth and the most habitable of all the planets in our solar system. Unlike Mercury and Venus, daytime temperatures on Mars can reach a relatively mild 20 degrees Celsius in some regions. However, at night, temperatures can plummet to minus 130 degrees Celsius in colder areas. One of the biggest issues on Mars is its thin atmosphere, which is mostly carbon dioxide with only tiny traces of oxygen, making it impossible to breathe. The low atmospheric pressure also exposes the surface to high levels of radiation, around 40 to 50 times more than on Earth, which could be deadly over time. Mars is also known for its massive dust storms, with winds reaching 100 kilometers per hour. While they wouldn't be strong enough to knock you over, they could last for weeks and block out sunlight, making life even more difficult. Surviving on Mars would require a well-insulated, airtight habitat with a reliable life support system to provide breathable air, warmth, and protection from radiation. Jupiter. Jupiter is the largest planet in the solar system, but landing on it would be nearly impossible. One of the biggest challenges is its extreme radiation, which is so powerful that even from 300,000 kilometers away, it would start tearing through a standard space suit. But let's imagine you had a hypothetical radiation-proof suit. First, you'd experience Jupiter's immense gravity, which is 2.4 times stronger than Earth's, pulling you down at an incredible speed. As you enter the outer layers of the atmosphere, you'd pass through freezing ammonia clouds at minus 150 degrees Celsius, all while battling hurricane-force winds reaching for 180 kilometers per hour. If you made it about 150 kilometers down, you'd reach the deepest point any spacecraft has ever explored, where NASA's Galileo probe was destroyed in 1995. Going further, the pressure and temperature would skyrocket. Eventually, you'd enter a strange state of matter called supercritical fluid, a phase between liquid and gas, making it feel like you're swimming through a thick, heavy substance. Deeper still, you'd reach metallic hydrogen, a bizarre, dense liquid that would trap you forever. If you somehow kept falling, you'd eventually reach Jupiter's core. The temperature here is a blistering 24 degrees Celsius, making it even hotter than the Sun's surface. No suit, no spacecraft, and no human could ever survive that journey. Saturn? Saturn, the second largest planet in the solar system, is a gas giant primarily made of hydrogen and helium. Getting there would be tricky. You'd first have to navigate past its 146 moons without crashing. Then you'd encounter its iconic rings, a dazzling collection of ice, dust, and space debris from shattered moons and comets. As you approach Saturn's equator, hurricane-force winds reaching 1,800 kilometers per hour would make it impossible to stay steady. Trying to enter from the North Pole wouldn't help either. You'd be met with a gigantic storm twice the size of Earth, swirling violently. Descending further, you'd pass through ammonia clouds, with temperatures plunging to an unbelievable minus 150 degrees Celsius. But as you continue falling, things start heating up, reaching a relatively comfortable 0 degrees Celsius. At this point, however, pressure becomes your biggest enemy, growing 2 levels comparable to the deepest parts of Earth's oceans. Going even deeper, the gases around you would turn into a dense liquid, trapping you in an ocean of hydrogen and helium. If you somehow survived long enough to reach the core, you'd find yourself in a molten, rocky center that's 10 times the size of Earth. Here, temperatures soar to a staggering 11,700 degrees Celsius, twice as hot as the Sun's surface, while the pressure is 1,000 times greater than Earth's. Thanks for watching. Please join as a member to support this channel. See you next time.